Okay. Oh, by the way, any questions from the lecture? Anything which you could not understand? I share my screen. Yes, Abiya, Hania, Kaima, any questions from the lecture?
No.
No? Okay. Okay, sounds good. Now, uh, just to recap, if you remember that in a series circuit, you've got to remember that the voltage is divided and the current is equal in all the resistors, right? And we went through all of this analogy of how charge is going to start with a complete bag of energy and is going to distribute charges. Sorry, it's going to distribute voltage across R1, R2, and R3, right? So that's how currents work in a series combination. And voltage is divided, current is the same, but how do resistances add up? Resistances basically add up in this way, right? They basically just add up in the regular way. They algebraically add up. RT is equals to R1 plus R2 plus R3. Why do we need to make this obvious? Because that's not the case with the parallel circuits, right? In parallel circuits, you've got to remember two facts: that the current is going to divide, the voltage is same across all of those junctions, and how do total resistances add up? Total resistances actually add up in this way. This is all just pretty basic IGCSE stuff, nothing new. We just went over it again, but this is all included, right? So IGCSE electricity is included in A levels, right? So it's not as if there's something different. It's in fact, A levels electricity is like 90% IGCSE electricity. We haven't even like done this anything different. It's just the same concepts, but with more, you could say, complexity and slightly higher difficulty in questions. You'll see that when we solve them. Okay, so the circuits are more complicated in this configuration, and it will require much more practice. And in IGCSE, you could just get away with learning like two formulas, and if it's a series, you can see it straight away. If it's parallel, you can see it straight away, and you can just apply your learned facts. But that won't work for in A levels. Okay. Okay. So we're going to see how resistances add up. Okay. So for example, how do resistances add up from A to B? So that's just, does it seem like series? Yes, it does, because the same current is flowing from 2 ohms, 2 ohms, and 2 ohms. It's series, right? The same, you could say, water is flowing through the single canal. So RT is just going to be equal to 2 plus 2 plus 2, pretty basic, which is going to be 6 ohms. Great. What about the one below? It's again series, right? So RT is going to be 2 plus 6 plus 8. And then, now, what about this one? Is the series or parallel? Now it's both, because you notice that the current over here is diverging into two paths. So that means these two resistances are, or you could say resistors are parallel, right? So how do I calculate the total resistance from A to B, right? So would it just be 2 plus 6 plus 8? No. You would first have to calculate the total resistance of this parallel junction, right? Now, how do you calculate that? 1 over RT is equals to, 1 over 2 plus 1 over 6, whatever that gives me. Now, there is a shortcut which I want you to remember. Okay. That is, so in fact, let me show it to you this way as well. So 1 over 2 plus 1 over 6, let me see what that gives me actually. That's my calculator. 1 over 2 plus 1 over 6, or you could just do it manually. Let's just save time. So 2 over 3 is equals to 1 over RT. So that means RT is equals to 3 over 2 ohms. 3 over 2 is 1.5, right? So RT is equals to 1.5 ohms. Now, 1.5 ohm. Now, this is the total resistance of just this parallel combination, right? So RT from A to B would be 8 plus 1.5, which should be equal to 9.5 ohms, right? So this is how you calculate series and parallel, because you could say that the resistance of this combined parallel resistor is 1.5 ohm, right? What that means is that you could very easily replace it with a 1.5 ohm resistor, and that's basically what we did, right? What we did was we calculated the equivalent resistance of another resistor, that if it had this amount of resistance, then you could consider it equivalent, right? So we're basically using this formula to convert it to a series resistor with that same resistance. So basically, this combination and another resistor in series would have the resistance of 1.5 ohm. So we're basically kind of like, grouping it down to a series resistor. In fact, that helps a lot when you've got very weird combinations of resistors. Then it makes sense to replace this entire parallel circuit to its equivalent series resistor. That's what we did. Okay. So the total resistance would be 9.5 ohm. What about this one? A to B. Now, how do I do this? 1 over RT is equals to 1 over 2 plus 1 over 6 plus 1 over 8, right? Make sure you remember that this value actually gives you 1 over RT. Yeah, that's a very common mistake. It gives you 1 over RT. It does not give you RT, right? So that means you'll have to take the reciprocal later on as well. So let's check what that is. 1 over 2 over 1 over 6. We're doing basic calculation even in A levels. 0.79 or 0.8, right? But that's 1 over RT. I want RT, so RT is going to be equal to 1, or it's going to be equal to 1 over 0.8. 1 over 0.8, which is 1.26. 1.26. So now check this out, by the way. The total resistance of this combined 2 ohm, 6 ohm, and 8 ohm is 1.26. Do you notice how much smaller the parallel resistors are, right? That's our, in fact, the primary uh, advantage of parallel combination, that it greatly reduces the resistance in the circuit. So that's why we prefer parallel circuits, where we want more current, right? So what does this 1.26 mean? That means that you could replace this entire circuit, this parallel junction, with a 1.26 ohm resistor. That's basically what we did, right? So we reduced it down to its equivalent series component. Equivalent series. Equivalent series resistor. Okay, and by the way, if you have any questions, stop me then. Okay, and then I'll explain it further. Okay, otherwise I will try to keep on moving on with questions. You can stop me, you can interrupt me. Please interrupt me as soon as possible. Okay, so question 5. Calculate RT from A to B. Total resistance between this junction. Now, uh, uh, they're all threes, right? But you notice there's a parallel one over here as well. So this one is in series, right? How do you figure out which one is series and which was in parallel? The rule is, if the same current is passing through a resistor, then they're in series, right? So check this out. These two 3 ohm ones are in series, okay? Then these three, because different currents are flowing through them, they are in parallel, okay? What about the last one? The last one is actually in series. So this one, and this one, they are all in series, okay? So why? Because the same current is flowing through all three of them, because it was the same current that flew, or passed here, and the same current that passed over here. Okay. So this would just be 3 plus 3 and plus whatever this equivalent total resistance is. What is the total resistance of this? Just do, whatever you want. You can do it by 1 over RT plus 1 over RT is equals to 1 over 3 plus 1 over 3 plus 1 over 3 plus 1 over 3 equal to that value. Let's check it out. In fact, 1 over, oh no, by the way, I wanted to tell you a shortcut. Okay. The shortcut is, rather than doing such a complicated multiplication, shortcut is, this is only applicable for pairs, by the way. Only for pairs in parallel resistance. Okay. This is a very important shortcut. So for example, if in a parallel resistor or in a parallel combination, you have two resistors, R1 and R2, right? Now to calculate RT, you had to do 1 over RT equal to 1 over R1 plus. So that's very long. So I'll write down the original one. This is the real one, the one with proof, okay? But for shortcut, what you can do is you can get RT by doing product over sum. Product over sum. What does that mean? That means in the numerator, you multiply the resistances. And in this denominator, you add the resistances R1 plus R2. This is going to give you RT. This is actually very convenient when you've got got lots of resistors and you want to save time, because this takes more time, right? More calculations, more calculator buttons pressing. So that's lost time. This is going to save you time. Remember, this is only for pairs. If you have R3, you cannot do into R3 and then you add R3 as well. That's not possible, right? You'll have to first find the total resistance of R1 and R2, okay? And then you can consider R1 and R2 to be one resistor, and then do product over sum with that other resistor again. Okay, I'll show you the application in the next few examples. Okay, so for example, yep, this one, right? In this example, what you would have done is you probably would have, you'd had 1 over RT is equals to 1 over 3 plus 1 over 3 plus 1 over 3. Generally, with three resistors, it is more convenient to do this method, okay? But I'm just showing it to you how to use the product over sum. But in this case, just easy, right? Just 3 over 3 is equals to 1 over RT. So their total resistance is 1, right? So how do you do it? Using the product sum. So let's find out the combined resistance of these two parallel resistors. Product over sum, not sum, product over sum. 3 to 3 over 3 plus 3, which is 9 over 6. So that means 9 over 6 is going to give me 3 over 2. So 1.5, right? So you could consider these two resistors to effectively be a 1.5 ohm resistor, okay? And now, since you've considered that the total resistance of this 3 and 3 is 1.5, now you can use the product over sum with the remaining third one, because this only works for pairs. So you have to make pairs of resistors, right? So this is one pair and this is the other pair, right? So calculate the total resistance of that pair. So that would be 1.5 multiplied by 3 over 1.5 plus 3. So 1.5 into 3 is, I think that's 1.4.5. So, yep, 4.5 over 4.5 equal to 1. So that's it, right? So you got the same answer either ways. So make sure you use it in pairs. So the total resistance of this 3 and 3 is 1. 1 and then plus 3 and then whatever that is. Moving on. Again, if you have any questions, stop me there and we'll do another example if you are confused. But this is all just IGCSE stuff so far. Okay. Question 6. We want to solve lots of questions today. So we'll have fast speed. Now, let's check this one out. How do I calculate total resistance from A to B? If you want to calculate total resistance, first check which is in series and which is in parallel. Now, this is a combination of like a lot. So first of all, this one seems to be in series, okay, because this just has a single current passing through it. But these ones have different currents passing through them, okay? Now, first of all, do you notice that these two are actually in series with themselves? So that means you can basically make the question a bit neater by saying that these two just add up to be 9, because these two together are in series. It's like series within parallel, right? Although this one and this one and this one, right? This has a different current passing through it. This has a different current passing through it, right? But if you zoom in, then this is just series, right? Because both of these resistors have the same current passing through them. So you could consider these two to be series and you can add their total resistance up to be 9. That's it. This is just 9 ohms, right? So you can consider this to be one large 9 ohm resistor. Okay. So what is the total resistance? This is just 2. This is just 2 plus. Now, what is the total resistance of the parallel junction? This is a 2 ohm resistor, and you can consider this to be a 9 ohm resistor, right? Now, what do I do? Product over sum. Calculation is faster. 9 into 2 over 9 plus 2, right? You just plug this value inside the calculator, and 9 plus 2. So the answer is 3.63, right? So we've got to be quick in our calculations, because electricity, that's like, it's very easy to do questions because the formulas are very simple. It's just It's just time taking when you do the calculation, so you want to be quick. Okay, moving on. Now, let's try this one out. So, calculate the total resistance from A to B. Seems very complicated, okay, but let's walk through it step by step. First of all, notice whenever you solve a circuit, see where the current is going, right, if it's possible. So, for example, you say that the current is going from here. So I can see that this 3 ohm resistor and this 3 ohm resistor, they're in series with each other. So you can just consider these two to be one large 6 ohm resistor. Okay. Now, what is happening after this point? You have approached a junction, which means the current is going to divide itself into two paths, right? So now the current is being divided into two parts, but what about this 6 ohm and 6 ohm? They're in series with each other. So you can consider these resistors to just be one large 12 ohm resistor, right? And then this 12 ohm resistor, this large 12 ohm resistor, is in parallel with the other 3 ohm resistor, right? So that's it. And you've solved the question. Oh, by the way, for example, let's say that I add another resistor over here. Let's say I add another resistor of 10 ohms over here, right? Now, how do I add this? This one is just going to be 3 plus 3 plus whatever their total resistance come out plus 10, right? Because this current and this current is the same. So you could say that this one is essentially in series with this one. So you could just as easily say that this was over here, right? It makes no difference. Okay, so how do you calculate the total distance? Uh, Total distance, yep, 3 RT is equals to 3 plus 3 plus. Now, find out the total equivalent resistance of the parallel resistors. So you can consider this just to be 12. So 12 into 3 over 12 plus 3 will give me the equivalent resistance of this parallel junction. So 12 into 3, 36 over 15, which is, you see how faster this shortcut is. So 2.4. 2.4 ohms is the equivalent resistance of these parallel junctions. So 2.4 plus 10, right? Whatever that is. Okay, moving on. Now, I would like you to solve this one yourself. Okay, so you just have to calculate the total resistance from A to B. It should not take you more than 3 minutes. 3 minutes is it's extreme. It's extreme. You do not need this much time to solve it. It's just a fancy circuit, but the rule is basically the same. Always try to dumb down the circuits, right? If they seem pretty complicated, try to group them together and see what are they effectively saying, right? You could have 100 1 ohm resistors, or you could just say that you have got 100 ohm resistor, right? That they're basically saying the same thing. You want to make your circuit more neat if you want to solve it right. Okay, I'll give you 3 minutes and then I'll write down the solution. Okay, let me write down the answer. So, first of all, you can make the question much simpler by redrawing it by simplifying the series ones, right? So this 3 and 6, they're basically series with each other. So you can say that they're both effectively just one 9 ohm resistor, right? What about the ones in the middle? They're also series with each other. So that means you could say their total resistance is what? It is 50. This is just 150 ohm resistor, right? What about these two? Again, this is just 30. Because 10 and 20, they have the same current flowing through them. So this is just effectively 30 ohm resistor, right? And then how do you calculate their total resistance? Now, in this case, if you have like three of them, it's just more convenient to write 1 over RT and so on because, you've got to make pairs twice. So it's not nice. So 1 over 9 plus 1 over 50 plus 1 over 30. So answer is 1 over 9 plus 1 over 1 over 50 plus 1 over 30. And then, just divide that over 1. So 1 over answer is. So RT is equals to 6.1 ohms, right? So this is the total distance from A to B. Okay, so that's how I solved it. Pretty basic stuff. Any questions, guys, before we move on?
No.
No? Okay. Okay, sounds good. So we were just talking about resistances for the time being, right? How to calculate total resistances if in case you forgot from IGCSE or you did not really understand this part in IGCSE or you just sucked at it. That's okay. Okay. So now you do not have any excuses that I did not know how to calculate resistances. Okay. So we've done multiple examples and now we're going to bring in the big guys, which are voltage and current. Okay. Now, listen very carefully. Okay. These are complicated circuits. They are like two steps ahead of IGCSE circuits. They're much more complicated and you've got to be careful. The concepts are exactly the same. There's nothing new at all, right? I am not talking about any single thing which is new in the A level syllabus, but the circuits are more complex. So you've got to be careful because in IG they were pretty basic. Okay, they would just give you like one resistor at the bottom, and they'd give you an ammeter and a voltmeter, and they'd ask you to calculate something something by using Ohm's law. That's it, and you got 3 marks for that. Okay, so in A levels, if you get a 3 mark A level questions, you should run for your lives. Okay, now question: I've got a 12-volt battery and I've got an ammeter. Ammeter is always in series, if you do not remember. And voltmeter is always in parallel, by the way. Voltmeter is always in parallel. Okay. And so I've got a 3 ohm resistor and I've got another 3 ohm resistor and I've got this like switch in the center, right? The question says, what is the ammeter reading if the switch is open? If the switch is open, then you can assume that this junction does not even exist, right? This is just like useless. It's just like a wire hanging out. Okay. What is the ammeter reading when the switch is open? If the switch is open, then you just assume that this is your outer circuit, right? How do you do that? V is equals to IR, right? How do you calculate the current? I is equals to V over R, right? Now, remember, because current is always total in this case. So that means you have to take the rest of them as total as well. So I total is equals to V total over R total, right? You can just say that, I will just use some random voltage and some random resistance. To calculate the current, to calculate the total current, you always need the total voltage in that junction and the total resistance in that junction, okay? Because we're talking about the total current of the entire circuit, then we have to consider the total resistance of the entire circuit and the total voltage, okay? Total voltage is 12 volt. And what is the resistance? 3 plus 3, 6 ohms. So 2 amperes is the total current that is passing through this circuit. Okay. Now, what if the switch is closed? If the switch is closed, do you notice that now the current has two paths to follow? Okay. And this is actually going to create a short circuit. This is basically what a short circuit is, right? It's pretty common to hear it short. This got shorted, this short circuit, and the short. So now, what does a short circuit mean? That means the circuit was literally taking a shortcut. And what happened was that current only likes to take the path of least resistance. Current prefers zero resistance. And what is that wire? Compared to this wire, this wire has zero resistance, right? So the current is actually going to ignore this path and it's going to take the path of this closed switch, which has zero resistance, right? Now, what is the effective circuit? There, no current goes over here, by the way, right? This is a short circuit. A lot of current is actually going to go from here, right? Because there is zero resistance in this junction. Then what's going to happen is that a very high amount of current flows, like, practically that's what happens. But we can make theoretical assumptions, and we can say that the circuit does not get broken and so on. But practically, if a short circuit does occur, then so much current goes through this wire. And when a high current goes through wire, what happens? You get a very large amount of heat, right? Whenever you have a high current, it means you've got a lot of colliding electrons with the atoms. And when they collide a lot, it generates heat. And when you have a very extreme amount of current, that heat is going to cause a fire. So that's why short circuits cause a fire. So theoretically, but let's say that a fire does not occur, then you could assume that this is the only circuit that is existing in this case, right? So this is the circuit, and you can just calculate uh, IT is equals to VT over RT the simple way. What is the total voltage? It's 12 volt. What is the total resistance? It is just 3, right? In this case, because you've ignored this completely. The only circuit that exists now is this one. So 12 over 3 is going to be 4 ampere, right? And you can, by the way, see if you halve the resistance, the current doubles, right? Because there's less resistance literally. Okay. Moving on. Now, let's calculate this. For example, I've got this setup, and what do I have to calculate first of all? Read the question. The question says calculate IT, so that means this total current. Then, by the way, IT is always the current that exits the battery if you're unsure. IT is always the current that exits the battery and enters the battery, right? So current is going from positive terminal to negative terminal all the way around this circuits, right? So current leaves the battery, flows through this 10 ohm resistor, then is going to divide itself into this 15 and 5 ohm resistor, right? Why do I have a separate ammeter A1 and A2 over here? Because the current through this is going to be different and the current going through this is going to be different, right? Because current is dividing itself. It's not equally dividing, it's dividing itself depending upon the resistance. Then once you combine that junctions, the current is going to converge again and then leave. Okay, so first of all, calculate IT. IT, just use Ohm's law, V is equals to IR. If you want to calculate total current, you need to have everything total as well. So IT is equals to VT over RT. I just divided it. Total voltage is 30 volt. And what is the total resistance? That's the tough part. Total resistance is just 10 plus 15 plus 5. No, it's not. RT is equal to 10 plus. What is the combined resistance of this? It's going to be product over sum. Just use the shortcut over here because it's easy. So 10 plus, you can just plug this directly in your calculator, 15 into 5 over 15 plus 5. Make sure to use brackets so that they don't get added directly. 10 plus 15 into 5 over 15 plus 5. So total resistance is 13.75. So 13.75 ohms, which means the total current is 30 over this answer, which is 2.18. 2.181818181882 amperes. Okay. But because we are not crazy, we can just say that it is 2.18 ampere. Okay. So what is the voltage? What is V1? V1, they've literally shown it to you that this is V1, which means what is the voltage drop that occurred across the 10 ohm resistor? Okay. Now, right now, listen very carefully. Okay. Because this is very important to see how to calculate the voltage drop in this resistor. And it's also important for the next junction. Okay. So how to calculate voltage drop? V is equals to IR, right? What is the current that goes through this resistor? It's 2.18. Multiply what is the resistance that is going through that current? It's 10 ohms. Let's check. So that is just 21.8 volts, right? So that means, what does that mean? Does that mean that like there is 21.8 volts difference over here or what? Like that means that there was a drop of 21.8 volts from this resistor, right? So that means, for example, you had 30 volts over here from the battery. Then what happened once the current had to pass through the resistor? You lost 21.8 volts. Then how many volts do you have remaining over here? You can subtract and find it out, right? This is important because that's important for the next junction. So 30 minus 21.8 is 8.2 volts, right? So what the voltmeter does is the voltmeter is literally calculating TD, which is the potential difference, right? What does the potential difference means? It literally means what is the difference in the voltage between this point and this point. That's why we connect it like this in parallel, right? The potential difference between this point and this point is 21.8 volts, which is also the voltage used up by the 10 ohm resistor. So 30 volts was over here, and this resistor, this mean little resistor, stole all our volts, and it's only giving off 8.2 volts to the rest of the circuit, right? Now this is where students get confused. What they do is, in fact, let me present the problem to you in the next question. So you figure out what V1 is. You've got the mark for that. How to calculate V2? For V2, what do you do? So V2, what they will do is they will try to do V is equals to IR. Okay. And they will probably make the mistake of saying that 2.18 multiplied by 15, and this is the voltage drop over here. But that's wrong because 2.18 is not the current that's going through this resistor, because the current was supposed to divide, right? 2.18 ampere is over here. It's the total current. But once you reach this point, the current is supposed to diverge into different paths. So you do not know what 2.18 is going to divide itself into, right? So in this case, what do you do? You're completely lost. You don't have I and you don't have V. So this was set up that way. So first of all, remember, for parallel, the voltage is the same, right? Remember the fact. In parallel circuits, it is the current that divides, but voltage input is the same for both of them, right? So that means, for example, if you have a battery in parallel with two resistors, right? If this is 12 volt, then this resistor will also get 12 volt and this resistor will also get 12 volt. So does that mean that this resistor will get 30 volt? So is this will get 30 volt and this will get 30 volts? No, that's incorrect, because this resistor ate up our voltage, which only left 8.2 volts remaining, which means the voltage that's going to go into both of these resistors is actually 8.2 volt and not 30 volt. So this voltage goes into both of the resistors. And now once you have voltage, you just have to figure out, you've already figured out V2 and V3. So 8.2 volt and 8.2 volt. That's all you had to do. No calculations were required. In fact, the calculation for V2 and V3 was done in the previous part, right? Now, calculate A1. This is just easy. To calculate A1, again, V is equals to IR. Just use the formula I is equals to V over R. I is equals to V over R. Now, what is V? I hope you guys are listening and you haven't slept. Ugh, physics is not for sleeping. If that was the case, then we should shut down all the sleep clinics in the world and just have them attend, physics classes. V, voltage. What is the voltage going through this resistor? That's 8.2. What is the resistance? That is 15. Let's check. So 8.2 over 15. So the current going through this is 0.54 ampere, right? Now or in fact, 0.4546666666667, right? This is popping up everywhere these days. So we can just stick to not being crazy and say that it is 0.55 ampere. Okay. Now, what about A2? How do you figure out A2? Same way, right? V over R. I is equals to V over R. What is the voltage going through A2? A2 is this one, right? By the way, That is 8.2 volt. And what is the resistance? 5. So 8.2 over 5. So 1.64 ampere is this current. And that's it. You've solved the question. And by the way, you can even check. So this is 1.64 ampere, and this was 0.55 ampere. If you check and you add up 0.64 and 0.55, it will add up to give you back 2.18 ampere, because it's the current cannot be lost, right? The total current exiting the junction should equal to the total current entering the junction, right? So clearly you see how the circuits are slightly complex than IGCSE, right? They have a little more detail hidden into them, which was ignored in IG. Okay. Any questions? Anything you would like to go over? We've got the next question as well. Yes, guys. Ariz, Ania, Kaima, Biha. So far, so
Yeah.
good.
Yeah.
Wow, you guys are all Einsteins. I did not get it at all when I learned it the first time. In fact, when I was in my O levels, this was the topic which hurt me the most mentally and physically and spiritually. Okay, let's move on. Of course, you guys didn't have such a great teacher. Oh, sorry, I didn't have such a great teacher. Okay, moving on. Next question. In fact, let me take a minute. I'll be right back. Okay, let's resume. Let's solve this question. Okay. So we have multiple questions. By the way, this is not just like a single mark question. This is like, 1 mark, 1 mark, 1 mark, 1 mark, 1 mark, and so on. So if you've got a circuits question that looks like this, it is generally worth around 4 to 5 marks. Okay. It depends upon the type of question. Of course, it could be 5 marks. It could also be 10 marks, depending upon the types of questions. And, there are often other components associated. This is a simple circuits, voltage calculation using Ohm's law and resistor combinations. That's it. This is all there is, right? We have much weirder and complex types of circuits as well, which I have not shown you. Okay. And in fact, they're not very doable with Ohm's law as well. In fact, let me scare you. Let me scare you. There are circuits which you are not really able to solve with Ohm's law because the circuits get very complicated. For example, like this. Now, there seem to be two batteries and they seem to be competing with each other and they seem to be multiple currents. Seems pretty weird. And what about this one? Now, this seems pretty impossible to solve with Ohm's law. Like what is my voltage? What is my total voltage? Where is the current going right now? If you try to solve these questions with Ohm's law, this question will seem impossible and you will hate electricity, right? And that's why there was another guy. He was called Kirchhoff. I have never figured out whether we call this guy Kirchhoff or Kirchhoff, but he figured out a law through which you can very easily solve all of the currents and all of the voltages, right? But in fact, that was not covered in IGCSE. This is the additional content which is in A levels. We'll go over that hopefully in the next class. Okay, so, but still, Ohm's law is actually fundamental. Now, for example, this question, you've got to find out A3, A1, A2, V1, V2. Okay, okay. So first of all, analyze the circuit first. Seems like a series and a parallel one. So over here, current is the same, but now current diverges, right? Current diverges, and then current is then going to converge back to A3 over here. This one is parallel, and these two combined are series. So you could say that this 5 ohm and this total series resistance is in parallel with each other. So let's calculate A3 first. A3, V is equals to IR. Make sure you use total when you calculate total current, because this is total current. It's leaving the battery. And IT is equals to VT over RT, right? What is total voltage? Total voltage is 10 volt. What is total resistance? It is 7.5 plus. Now, what is the effective resistance of these parallel combinations? It is 5. You can consider this 3 and 2 to just be 5, by the way. So this is just 5 into 5 over 5 plus 5, right? Because I considered this parallel and this parallel, right? So product over sum, 5 multiplied by 5, 5 over 5 will just give you the total resistance of this total value. So 7.5 plus, I'm so hungry. It should give you 10 ohms. So, oh, great, excellent. So current is 1 ampere. Brilliant. So what about A1? A1 is this. Okay, so current going through this resistor. Let's check. So IT is equals to VT over RT. Okay. No, this isn't IT exactly though. This is just current going through that junction, V over R. Now, if you want to figure out the current going over here, you have to see what is the resistance. The resistance is 5 ohms. I know that. But what is the voltage going through this one? Is it 10 ohms? So if the battery is 10 ohms, you would say that this is going to get 10 volts and this junction is going to get 10 volts. But that's wrong, because there is this bully standing over here which is going to steal all your voltage, which means the remaining two ones are going to get very little voltage. So first you've got to calculate V1, right? How do you calculate V1? V1 is just equal to IT times R, right? What is the current that's passing through them? This is just 1 ampere. So that means 7.5 volts. So 1 multiplied by 7.5. So V1 is equals to 7.5 volts. That means 7.5 volts were lost in this resistor. How much voltage remains? Both of these junctions get 2.5 volts. 2.5 volts, right? So, so this would just be 2.5, right? Because that junction got 2.5. So 0.5 ampere current. Now, what is A1? 0.5, and what is A2? Now, check this out. There is another way to solve junctions as well. Notice that the total current entering was 1 ampere and 0.5 ampere went over here. Then it's logical to say that 0.5 would go over here, right? Because if total is 1 and 0.5 went over here, then exactly half would go over here, right? So you could make sense that way as well. Or you could do it directly as Ohm's law as well, right? And by the way, check it out. The total voltage of this is also 5 ohms. Sorry, total resistance of this is also 5 ohms. So you can see you get the same mathematical result as well. So A2 is also 0.5 ohm. So you can solve it using, the current entering and the current exiting as well, right? And what was V1? We figured that out, 7.5 volt. What was V2? V2. Have you figured out V4? Yep, V4 has been figured out. 2.5 volt. Okay. Now check this out. V2 and V3. Be careful. They're not asking for the total voltage at the junction. They are asking what is the voltage drop over here between these 2 points, right? So, because notice this is, if you zoom in, this is just a series circuit where the input voltage, is 2.5 volt. Then because you have a 3 ohm resistor that is going to use up some voltage and then going to give off the remaining voltage to the next resistor, right? So can you calculate how much voltage was lost over here? Yes, you can. V is equals to IR, the legendary formula. Now, Ohm's law. What is the current going through the junction? 0.5. What is the resistance? 3. So 1.5 volt. So 1.5 volt was lost in this resistor, minus 1.5 volt at V2. Right? Okay. And what is V3? So a simple way, you could just very easily figure out it's 1 volt because voltage entering was 2.5, 1.5 was lost over here. That means that that means that 1 volt would be lost over here, right? Or you could just use Ohm's law. 0.5 ampere multiplied by 2, which is equals to 1 volt. So 1 volt was lost over here, right? So you can do it using logical algebra, or you can use Ohm's law. In fact, Ohm's law is literally built upon a few logical algebraic, you could say, basis. That's it. Okay. And that's it. That'll be all. I would recommend that you solve this question by yourself. In fact, I'm going to give you this question as an assignment, which I would like you to send back to me within like 10 to 15 minutes. Okay. And I have left this weird looking complicated example as well. Okay. And if you solve this right, I've even given you the answers over here. Okay. If you're able to solve and get the right answers, then you have mastered, IGCSE style, very hard, very extremely hard, challenging circuits question, right? We haven't talked about Kirchoffs laws yet, right? But you will have mastered Ohm's law and circuit combinations and voltage and currents. Okay. If you're able to figure this question out, it's very easy. It's just the same kinds of concept, but it's just a larger circuit. So you'll have to break your question down into parts. Okay. So make sure to solve this one. Try to send it back to me within, 10 to 15 minutes. And I would recommend that you solve this as well. Okay. If you solve this, then that's perfect. Okay. Yes. Any questions? Yes, guys. Ares, Abiha, Anya, Kaima.
No, not any.
Okay.